Enrico Fermi, an Italian physicist, led the team of scientists who created the first self-sustaining nuclear chain reaction. On December 20, 1951, EBR-1 became the first power plant to produce usable electricity through atomic fission. It powered four 200-watt light bulbs and eventually generated enough electricity to light the entire facility. Chicago File 1 was the world's first nuclear reactor, built in 1942 by Nobel Prize winner Enrico Fermi. The reactor was built underneath the University of Chicago's Tech Field football stadium. The law of conservation of energy is that energy cannot be destroyed or created. It can only be changed from one form to another. That means that energy cannot be wasted because wasting is similar to destroying it. With the presence of energy in the world, energy is very helpful for humans in everyday life. As in the iron there is a process of changing energy, namely from electrical energy to heat. Energy is the power to do work that produces light, heat, or movement, or fuel or electricity used for power. My father and energy, they are the same. It gives me things to do work. Fission reactions can occur in every atomic nucleus of an element without exception. However, the easiest fission reaction is the reaction in the nucleus of uranium atoms. In uranium, the easiest reaction to occur is uranium-235, while uranium-238 requires more energy for this fission to occur. The fission reaction occurs when a neutron hits uranium-235, and at that time, the uranium atom will split into two Kr and Br atoms. When a fission reaction occurs, a very large amount of heat energy will also be produced. In the work process at the nuclear power plant, the energy from this fission reaction is used as a heat source to produce water vapor. The resulting water vapor is used to turn turbines and make the generator generate electricity. Nuclear plants cool the steam back into water in a separate structure at the power plant called cooling water. Or they use water from ponds, rivers, or the ocean. The cold water is then reused to produce steam. When uranium-235 is hit by a neutron, there will also appear 2 to 3 new neutrons. Then these neutrons will hit the other uranium again and appear again 2 to 3 new neutrons again. A reaction like this will happen continuously, slowly in a nuclear reactor. In nuclear fission, atoms are split apart to form smaller atoms, releasing energy. Fission takes place inside the reactor of a nuclear power plant. At the center of the reactor is the core, which contains uranium fuel. The uranium fuel is formed into ceramic pellets. Each ceramic pellet produces about the same amount of energy as 150 gallons of oil. These energy-rich pellets are stacked end to end in 12-foot metal fuel rods. A bundle of fuel rods, some with hundreds of rods, is called a fuel assembly. A reactor core contains many fuel assemblies. The impact of nuclear power plants on the future may be said to be unfavorable because nuclear power plants can only last for 40 years, while the fuel plutonium, which is a radioactive substance, has a half-life of 24,000 years. Jepara Lilo Sonario in 2011 said that this means that it will take 24,000 years to halve the radioactive power of plutonium. No building on Earth could last that long, so it will be stored where the radioactive waste from the NPP. From this statement, we can know that a power plant is indeed good because its impact on the environment is not like a coal-fired power plant. Power plants can be considered good if it's still usable, but what if 40 years have passed? Where do you want to put the radioactive substance? Humans will pass like the wind if the radioactive substance are only left alone. Therefore, the use of nuclear power plants cannot be used as the main power plant. In the nuclear reactor, there is power in it. Power is work divided by time, while work is equal to kinetic energy. We can use this formula to calculate how much power a nuclear reactor has. In order to further your understanding, I have an example. Let's say the radius of the pipe is 2 meter and the velocity of the steam to come out from the pipe is 10 meter per second. How many power does the nuclear reactor has if the density of the steam is 750 kilogram per meter cubic and the generator efficiency is 70%. From the statement mentioned in the previous paragraph and some calculation done, we can write it with the formula below and get the result.